today we're going to getting more into circles, guys. We've done circles before. We've done vertical angles in circles. We've done the circumference. We've done the area with circles. We've talked about radius and diameter and lots of different things. So this set of notes is going to kind of encompass some of the things that we need to review. It's also going to be some of the new stuff, which is talking all about arcs and arc measure and arc length, and that there is a difference between the measure of an arc and the length of an arc. And you need to know because it's going to ask you both questions on the test. They're different. Pay attention. Okay, guys, here we go. First things first. First, you're going to go through and name these things. Guys, this is a circle. To name it, you name it by the center point, so it's going to be called circle E. You cannot just call it E because E is the name of the center by itself, just the little letter. You can also, when you name a circle, put a circle and a dot in the center of it and put E behind it. Right? That's the name of that circle, circle E. Don't put just a zero with nothing in it because that's literally a zero or an O. Okay? You got to put the dot in the center to make it a circle E. Okay? The radius is going to be from the center out, going in any direction, any of those segments that connect the center of the circle to the outside edge. So in this case, there are 4 of them. EC is one example of that. Okay, name the others, guys. EB. If we go EB, what's another one, guys? Someone else, come on. ED, and then what else? EA. Perfect. Those are the 4 radii, guys. From the center, all the lines that go to the outside edge, those are going to make your radii. Questions, concerns, anything about that concept? Okay, double a radii, when you multiply it by 2 or go the entire distance from one side to the other, it goes to the center of the circle, that's going to be called a diameter. There's only one in this case, and it's going to be DB. DB or BD, it doesn't matter which order you go in, as long as you have those 2 letters. Now, the next one is something that we're going to use a lot. Listen to me. There's going to be 2 different types of angles in a circle. There's going to be what we call central angles, which we've talked about one time before, and there's going to be what we call inscribed angles. Inscribed angles and central angles, you have to know the difference between. Today we're only doing central. Guys, they make sense. The point in the middle of the angle is going to be the center of your circle. So what letter has to be in the middle of every single one of your angles? Which is what? E. E has to be the middle letter. Every time. Whatever the center is, if it's a central angle, it's got to be in the middle of your name of your angle. So I'm going to name one of them. I name the most obvious usually, is CEB. CEB. This is what it looks like. It goes from C, goes down to E, and then goes out to B. That is a central angle, where it has the center as the middle letter of our angle. Okay? So name me another one. What's a different one? C, say it one more time. CEA, nice. And most people don't name that one because they think I've already used the other piece, but that is perfect. Nice. Most people don't do that. That's great. Give me another one, guys. What was it? BEA, perfect, the little one. What if I said I wanted you to name this central angle right here? Which one is that? DEA. E just has to be in the middle. Okay. Anybody have any questions about any of those? Okay, let's do that again, just with the picture. You're going to go through and you're going to tell me the answer to these. What's the name of the circle? Circle D. Circle D. The center is what? D. Just D. Just D. The radius, you give me 2 of them. 2. Okay, so I heard DE, I think was the first one I heard. And then what's another one? DC. You could also say DB. That's another one, just in case you did that one as one of them. It's fine. You could put 3 of them if you wanted to. Okay. A diameter. There's only one of them. EB or BE. Doesn't matter. I'll put BE just to show you it doesn't matter which way it goes. EB, BE. And then, guys, there's lots of central angles. Let's just name 2 of them. Okay. C, D, B. That's going to be this one right here. What's another one, guys? EDC. Let's see. EDC. EDC. That's going to be this one right there. Good. You could name ADB, EDB, but that's a straight angle, and most people don't understand the concept, and it messes people up. It deals with something we get to in a minute. I wouldn't suggest naming those. Okay, guys, from here on, the next two things we're going to talk about, guys. If you have a radius and you want to get to a diameter, okay, what do you do? Multiply by 2. If you have a diameter, let me move that down a little bit because I'm going to write above it. If you have a diameter and you want to go to a radius, what do you do? Divide by 2. Okay, you got to know that because they're going to ask you questions like this. If CD is 16, CD is this piece right here, is that a radius or a diameter? A radius. If that's the radius, to get to a diameter, we'd have to take that 16 and multiply by 2, which would mean that we have a length of 32 inches. 32 inches. Right. For the next one, EB is equal to 7 meters. EB is equal to 7 meters. So is EB is right here and it's 7 meters. Is EB a diameter or a radius? Diameter. So if I want to take that 7, what do I have to do to that 7 to make it into a radius? Divide by 2, which would make it 3.5. And that would be meters.
You don't square the inches.
No, you don't, because this is a distance. So distances are not squared, only area. Good question. That'll show up more as we go forward. Anybody else? Okay, guys, now listen to this. When you have central angles, they make a circle in the middle. What does every circle on Earth add up to ever? 360 degrees. 360 degrees. All y'all got that. That's great. So 360 degrees is going to be the sum of all the central angles. Around here, they add up to 360 degrees. Every circle adds up to 360, guys. Okay, so that's the basics about central angles and the basics about circles. Now we're going to introduce a new concept for some of y'all. Some of y'all have never heard of an arc before. Some of y'all have heard of one, but you don't really know what it is mathematically. So let's talk about this. Guys, if you're looking at this picture, if I start at C, that's an endpoint, and go down here to A, that's another endpoint, that's an arc. Okay? It's like the crust of your pizza. Remember how you get a pizza slice, you eat it to the crust, what's left over the crust is like an arc. Okay? It's a piece of the circumference of the circle. That's what it really is. It's like taking that outside edge and cutting off a piece. That piece is your arc. Okay? So, we're going to use that to find the measure of minor arcs, using the central angles. Guys, whatever the arc is, the central angle is going to be the same. Whatever the central angle is, the arc is going to be the same. If you know one, you know the other. Okay? So we're going to use the math down here on our circles to find the missing angle first, and then we're going to find all of the arcs. All of the arcs. So here we go, guys. Every circle adds up to 360, just like triangles. It's the same concept as a triangle, except instead of adding it up to 180, you're adding it up to 360. So you add the 155 and the 98. That's going to make it 250 something. Is it what? 253. And then 360 minus that 253 would leave you what? 107. Perfect. We've got all the central angles now. Guys, if the central angle is 107, then the arc attached to it, this arc right here, this piece from here to here, has a measure, not length, measure. How many degrees out of 360 would that arc measure be? It's the same. That's all it is. It's 107. So if this one's 98, this one's 98. If this one's 155, then this one's going to be 155. They're the same. Whatever the measure is of the central angle, the arc is the same measure. That's it. Okay, here we go again. For the next one, 111 plus 90 plus 106. Y'all tell me, because I'm not going to try to do that. What was it? 307. It's just bigger than I thought it was. And then 360 minus 307 is going to leave you what? 53? Okay. 53 goes right here for the angle. Guys, once you get the angles, the arc part is easy. This one would be 111, this one would be 90, this one would be 53, and this one would be 106. Okay, we're going to pause for a second. Guys, you don't have to draw this, but it might help you if you can sketch quickly. Okay, I'm going to give you another circle. We'll talk about 3 in a second, but I want to just kind of add this in as an extra thing. If you had one where you had a diameter like this, and you had one going straight up, and they told you this side had a right angle symbol, and then down here like this, and I tell you, let's come up with an easy number, like 30. Okay? You should be able to find all these angles from old stuff. This is old stuff. You got to remember old stuff. Guys, if this side has a right angle symbol, how much is it? 90. And if this side is 90 and this is a straight line, then how much is this side?
90.
It's also going to be 90. And then I can find this one down here because every straight line adds up to
20.
So if I take it and think about this straight line, and I take 180 and I subtract this 30, how much is that going to leave for this other one? 150. There you go. There's also one more thing. Again, you don't have to draw this, but I'm just putting it on here so you can see it. Guys, there's also the concept of if you had like this and two diameters crossed each other. What kind of angles are these two angles? Vertical. And vertical, if one of them is 40, then the other one's got to be 40. And then you can find the others because they add up to 180. So this would be 140, which if this one's 140, then this one's going to be 140. It's like old stuff creeps into this new stuff, but I just wanted to kind of refresh your mind because some of y'all, you just forget those kind of things. And it's not even that you forget, it's that you don't know to look for it, that you know how to do it. You don't connect the old stuff to the new stuff. Okay, guys, here we go. Last one of these is going to be every circle adds up to 360. So if we have x plus 2x plus 4x, it's going to equal 360 degrees. Well, what is x plus 2x plus 4x? 7x equals 360. Now divide by 7. We're going to need 2 decimal places because I know it's nasty. It's not a nice number. So 51.43. Okay. 51.43 is going to be our ugly number. Round it off to 2 decimal places because it's in the problem. It's not our final answer. And then we're going to plug it into each one of these. Well, for x, it's just 51.43, but we do need to round that off to get to a final answer, so it'd just be 51.4. And if the angle is 51.4, then the arc is also 50. Guys, y'all getting the concept? Central angles are exactly the same. It's not that hard. We just got to make the connection. On the next one, it's going to be 2 times 51.43. It's like 10 something. Do the math on that, guys. 8. Rounded to 1 decimal because that's our final answer. 9. Okay. 102.9. I think that's what the first person, yeah. 8 or 9, I can't remember. 102.9. Good. And then the last one is 4 times that 51.3, or 51.43. What is that rounded to 1 decimal place? 205.7. Y'all agree on the rounding? Okay. So that arc would also be 205.7. So for the basics of the arc, anybody have any questions, concerns, finding the measure of those, anything about that? We're good on that? Anybody still writing? No? Okay, let's keep going. Here we go. Off phone while we're doing notes. Sweet. Y'all wanted to have me make you turn a phone in, be doing that while I'm talking up here. Come on. Focus. Pay attention. We're getting notes done. So here we go. Naming a minor, major, and semicircle. This is a big concept, guys. A lot of people do not know how to do this even after we get done because you don't listen to what is important. What's important is that arcs are only on the outside. The outside. You never cut through the inside. Minor arcs are going to be between, this is kind of like acute angles, right angles, and obtuse angles. Minor arcs are going to be between 0 and 180 degrees. Okay? because half of a circle is 180. So it's something less than a half of a circle. It's named by 2 letters. That really matters. It makes a huge difference. So if you're looking at this picture and I say AC, from A to C, do I go from A to C the short way or the long way? Because I only say AC, it's going to be the short way because it's the small angle. It's named by 2 letters. So this would be called arc, AC. Or guys, there's a symbol for it just like there is for everything else. It's an arc over the top of it, but it has to arc. If it's a straight line, that's wrong because that's a segment. So make sure it actually arcs. Okay, and then the measure of arc AC, that's how you write it. Measure AC, put the arc symbol over it, equals. Guys, if the central angle is 100 degrees, then the arc is also going to be 100 degrees. This is measure, not the length, the measure. Length is going to be like 2.7 inches. This is how many degrees out of 360. Okay, a major arc is different. A major is between 180 and 360. Guys, it's not the whole circle, and it's not the semicircle. It's not exactly 180. It's anywhere in between 180.1, 359.99999. Those are all in between that. Right? It's named by 3 letters. This is really important when we show this. Guys, if I start at A and I tell you that I'm going to talk about arc ADC, arc ADC, what does adding that D tell you to do? Instead of going from A to C, we're going to go, instead of going on the right, you're going to go on the left, and you've got to go from A. You've got to pass through D before you get to C. That's how you know to go around that direction. You can't go through C first. You can't go the short way because that would hit C first. You got to go from A, then through D, and then down to C. That makes it a major arc. You can also say ADC with the little arc thing above it. And then the measure of ADC, the measure of arc ADC, guys, you should be able to find this. Every circle adds up to 360. And if you take that 360 and subtract the 100 that they've already used up for the minor side, that's going to leave you 260 for this major side. 260. Questions, concerns, anything about the major? I will tell you that semicircles cause the most problems out of any of them. You'd be surprised how hard this is. Guys, if I am going to talk about a semicircle, it's going to be exactly 180 degrees. However, it's not a straight line. It does not go through the center of the circle. It's still an arc. So it's got to be on the outside. It's got to be the outside piece on the left or on the right. It's named by 3 letters. Why do I have to say 3 letters? Because I have to know, do I go from C and go to the left and go down to A, or do I want to start at C and go to the right and go down to A? So that middle letter tells me which side I'm going on. If I tell you that I'm looking for arc CDA, I would start at C, I would have to go through D and then end up at A. It tells me I have to go on that left side of that circle. Okay. It's also called excuse me. I could write it. CDA with the little arc symbol over the top of it, just so we're clear. You can always do that. Most people name arcs that way. They don't write the word arc. And then the last thing, the measurement of arc CDA. Guys, the measurement of any semicircle is how much? 180 degrees. If I wanted to name the other side of this, could I name the other side of this semicircle? Why not? I don't have what? I don't have the middle. I don't have a point in the middle. If I have to have another letter to name it. I don't have that one in the middle. So I would have to have something else here to say like arc CEA to tell me to go on that side. Okay. Questions? Naming it's more important than you know. Okay, guys, let's keep going. Okay, from there, Okay, we're reviewing circumference. This should take us no time. This is just to review the concept. Guys, the formula, I would even just cross out the one with diameter, because if you use diameter, when you go to use the one with radius, you're going to forget the 2 or vice versa. I would just ignore the one with diameter, and every time you have a diameter, the very first thing I would do is cross it out and cut it in half and make it into a radius. If the diameter is 9, what's the radius going to be? 4.5. Put that on there as your radius. Then the circumference formula is easy. The formula is 2 times pi times the radius, which is 4.5. Same thing over here. 2 circumference equals, 2 times pi times what's the radius? 10. Guys, what are you doing? You're just multiplying the 2 times the radius. That's it. And you put the pi at the end. So these are really quick. 2 times 4.5 is 9 pi. And that would be feet. It is a distance still, so we're not doing area, no square. Same thing on the next one. Just multiply the first number and the last number. That's going to be 20 pi. And that's going to be meters. Good. That's going to be meters. That's just a review that was on your last test, but not everybody got that right. Dylan, put it away in your bag. Next trip's to the office. Thank you. So, from here, and I don't want to do that on a Friday afternoon at 5th period. Don't do that to yourself. Okay, here we go. Arc length. This is what's different, guys. This is a measurement. This is like taking a string and measuring the piece of the arc. This is not out of 360. This is going to use the arc measure, but it is not out of 360. To do this formula, it is going to be circumference times the number out of 360. Circumference, I'm going to give you the whole formula, guys. I'm just telling you, that's what it is. Circumference times the number out of 360, which would be 2 times pi times r times the number out of 360. So it's basically circumference times the arc measure. That's what we're doing. Okay, before we do anything, we need to know which arc we're talking about. So for AC, it goes from A, it goes the short way to C. This is the one we're talking about. What is the measure, not the arc length, the measure of that arc? 32. You got to have that. That's the number you put over 360. So you got to have that. Yes, ma'am. This, where? That's an R for radius. R for radius. Thank you for asking. This one right here, we're doing arc ADC. We're going to go from A. We have to go through D next. We cannot go through C first. We got to go from A around to D and then around to C, all the way around the outside. And I need the arc measure there. Guys, to get the arc measure, what are we going to do? What's it going to start with? Every circle starts with what? 360 minus that 110, which would leave you 250. Got to have the arc measure to do these problems, guys. So we're doing the arc measure first. The next one is going to be arc CDA. If you start at C, you go to D, and you end at A. Guys, you don't need to think about this. If it connects the ends of a straight line, then the measure is how much? 180. 180. Okay, those are the arc measures. Now we're going to find the arc length using this formula. Okay, here it goes, guys. It's not bad. 2 times pi times what's the radius in this picture? 6 times the number 32 out of 360. Okay. This is let's type it together. So get that written down, then we're going to type it together. Okay. Do you type pi in your calculator? Yeah. Yes, ma'am.
Oh, you said
For the, say it one more time. Oh no, we have to use something to that. Oh, I was going to get there when I got there in a minute, but I haven't yet. I'll do that in just a second. Thank you for saying something. You've got ahead of me, but yeah, that's great. That's awesome. Okay, guys, here we go. 2 times 6 times 32 fraction button 360. I'll say it again. 2 times 6 times 32 fraction button 360. What is that going to give you for a, well, first of all, is it, I think this ends up being an improper fraction, so you have to do that second fraction button thing. And then it gives you what? 16 over 15. And what do you put after it? Because we didn't type it in the calculator. Pi. And the units on this would be inches. No square, because we're not talking about squaring anything. That would be your answer. Say it one more time. Yep. Just stays a fraction. Yeah, because we're not rounding, we're not uprooting it. Yeah. Since it's in terms of pi, we're just going to leave it like that. And the next one should really surprise me. Yes, ma'am.
So it's 2 times 6 times 32 and then,
Fraction button 360. Yep. Let's try it again. Let's try it on this one. Let me know if you get this one. So this one's going to be 2 times pi times what number is the radius in this problem? 7.2. Times the number out of 360. Which number am I using out of 360 on this problem? 250. The 250, not the 110, the 250, because we're talking about the part where, that's why I marked it and did all that first, so I didn't mess up that part. Okay, try typing this. Clear it out. It'd be 2, because this surprised me answer-wise, 2 times 7.2 times 250 fraction button 360. It ends up being a whole number. Did y'all get 10? Yeah. I was very surprised with a fraction and a decimal. We ended up with a whole number. So it ends up being 10 pi, and that is meters.
Not squared, right?
Not squared, because we're just talking about taking a string and measuring around the outside. So it'd be like the string starts here, goes around to here, and stops here. Good. Okay, last one. Oh, wait, question. I thought I saw a hand. No? Okay, last one. 2 times pi times, here's where we run into a problem, which she already pointed out, which was great that she saw that already. Guys, do we have a radius? No. So the very first thing, we got to make sure, we got to get rid of that. That's going to be 10 and 10. So 10 times what number out of 360? 180 out of 360. I was also surprised by this because it's, did y'all get 10? I was like, how did I manage to do a problem with a decimal and a fraction and then a different problem with a different measurement altogether and end up at the same answer? Like different arc measures, different radius, and I ended up at 10 pi again. Very surprising, very hard to do. If you wanted to do that, I could never make that happen. So your answer is 10 pi feet. Okay, questions, concerns, anything about it? Nicely done today, guys. I know it's a lot of material, so I want to make